Okay, the homework from section 2.1, 2.2, 2.3, the first one will not be due this weekend. It'll be due at least either on Monday or Tuesday. And I think we should be able to finish those sections on Monday. But I don't think I can finish them today. The most probably it's going to be due on Tuesday because I'm not confident that I can finish it on Monday as well. So I think last time we ended on this slide. So remember the difference between a sample and a population, right? And you have a statistic, which is a quantity calculated based on a sample, and then you have a parameter, which is a quantity based on the entire population of measurements. So the couple of examples that I gave you on this, if you are looking at the voter preference in the 2016 election. So in that case, let's say you're looking at what percent of voters prefer Trump. So there is a true percent of voters who prefer Trump, right? That we don't usually know, right? But we want to know, we want to estimate, right? So the true percent of all voters who prefer Trump, that's a parameter because that's a quantity based on the entire population of voters, right? On the other hand, you pick a sample of 1,500 voters and then you come up with what percent of the voters in the sample prefer Trump, right? So in that case, that percent based on the sample is a statistic. Okay? So you use the statistic in order to estimate a parameter, right? Okay, so so we know what a variable is. Anybody remembers what a variable is? Yeah, a variable is a trait or some sort of traits or characteristics of certain individuals or objects of interest. Variables could be categorical or quantitative. Quantitative variables are variables with numerical values. Categorical variables are variables like hair color, voter preference. So categorical variables basically divides the individuals or objects into categories or groups. So if you look at hair color, let's say the hair colors are blonde, black, red, I don't know, what else is there? What was that? Blue? I don't think that's the natural color. Let's just say those three for the sake of the class. Okay, so then basically what you're doing is you are looking at all people and you are dividing them into three categories, right? People with black hair, people with blonde hair, people with red hair, right? Is that making sense? Voter preference that we had, that's also a categorical variable, right? It's not a numerical variable because the voters are basically saying who they like, right? So in the 2016 election, what are the possible values of voter preference? it could be Trump, it could be Clinton, that's another choice, and it could be none, right? Right? Sometimes you wish that you had that third option, but you don't have that. Okay, so okay, so that's everybody understands the difference between the two? Okay. And I'm going to come back with some examples in a bit, but I wanted to give you some examples of the statistics around us. Certainly, one of the reasons statistics, even I posted a video in Moodle, right? The joy of statistics. If you have seen it, you have seen a little bit of a history of the statistics. Statistics started with the kings and queens who wanted to know the demographics of the country, okay, of their kingdom. So, I think I forgot which country it was, Netherlands or some other country. They thought they were, superior to any other country in military and stuff. They thought they had a large army. Well, in those days, large army meant you have lots of adult men in your country. And pretty soon when they actually did this statistics, they found out that they weren't really that superior. Okay? So the point is, governments do a lot of statistics. So you have a lot of government agencies doing a lot of statistics because we want to know what's the population. We want to predict what the population will be in the future, things like that. And other examples would be, how many barrels of gasoline do we use per day in U.S., let's say, right? And that's 9.3 million barrels of gasoline. Why do we care about that? Well, we want to know what is the current need of gasoline in the country. 43 million households own dogs. Who would care about that number? Well, if you have a company specializing in dog food, right, you would care about in numbers like this. U.S. estimate of retail food sales, that's $4.4 trillion. Again, if you are, you would care about that because the bigger, if it suddenly shrinks, that tells you that there is some problem in the economy, right? If it is big, you know that something good going on in the economy, right? And also if you're in the retail food business, you would also care about things like that. 32 million U.S. businesses, so that's how many U.S. businesses out there. Again, those are indicators of what's happening in the economy. 20% of corn crop is exported, so that gives you an idea of the demand of corn outside of the United States. And you can compare that to the actual demand around the world, and maybe you can do better or not so better. So again, you would want to know numbers like this if you are producing corn to export. 1.6 million bachelor's degrees awarded. Again, you want to know the education level of people in your country, right? If the education level in your country is low, pretty soon you'll get behind, right? If it is, you want to keep it at as high as possible, right? 57.6 million people received SSA benefits. Number of deaths per year from traffic accidents is sort of little. If you look at the number of deaths per year, or even number of accidents per year, traffic accidents, it is nearly constant year by year. Okay, so per year number is more or less constant. Who would care about that? Well, insurance companies for sure will care about that, because when they look into what they should be charging everybody, that's one of the things that they will need to know. Average income level of a typical family. Why would you want to know something like this? Again, you want to know how average families are doing economically, right? Does anyone know right now the average income level? No? No? Okay. When you take, any of you have taken economics courses? Okay, everybody should take some economics courses, right? And also inflation rate. So it's clear that why would you care about the inflation rate? For example, I care about it because when I see inflation rate is 2-3% and then my income is not going up by that, right? That would be a bad indication of the situation. So average income level of a typical family, I don't exactly know, but I can sort of give you the percentile. So I believe the lowest 60-70% of the families, the typical income is about $50,000. So if you look at the lowest 60% of the families, or maybe it is 50%, but 50-60% of the families, their family income would be somewhere around $50,000. Okay. So that's what we have right now in the United States. Now again, why you want to care about those is because you have that data for many years in the past, and then you want to see what's the situation as how things are progressing to today. So if the income level, once you take into account inflation rate, look into the income level, right? Obviously, the income you see now will be bigger than what you had, let's say, 10, 20 years ago. However, the key is to look at the income when you take into account the inflation rate. Okay, then you can compare them. And when you compare them, you want to look at, hey, has it been decreasing? Has it been increasing? Right, things like that. Am I making sense? If it has been increasing, that tells you that overall most people have been doing better. If it has been decreasing, that's an indication of what? Overall, a lot of people are doing worse. Right? Again, so these are the indicators that economic and a economist will be interested in to study the economy. Okay? There are, a lot of the time, a lot of people complain about the federal agencies like this. What's the need of all these agencies? But if you want to have a modern economy, and if you don't do all these tasks, well, you cannot sustain the modern economy. You need information to keep yourself updated on the situation that's happening, right? So federal agencies producing data about people, economy, and the infrastructure. So Bureau of Economic Analysis, so they do a lot of the economic stuff. Bureau of Justice Statistics, Bureau of Transportation Statistics, Bureau of Labor Statistics, U.S. Census Bureau. If you get a package in your mail from the census, by law, you have to complete it, right? So, Economic Research Service, Department of Agriculture. If you don't tell anybody, I actually missed this one once. National Agricultural Statistics, Energy Information Administration, National Center for Education. Remember, I said I missed it, so you don't know which one I said, right? that's the key because it's being recorded. So, okay, National Center for Education, National Center for Health Statistics, Environmental Protection Agency, and so on. I think that's usually called EPA, right? So let's see some of them. I wouldn't want to look at all of them. So Census Bureau, the first task is they want to count the population. So population count is one of their agendas. And National Center for Health Statistics, this agency produces general purpose health data. So the number of deaths from heart disease, I don't know what year it was, but in some year it was 630,000. 20% of people had at least one ER visit. Number of births, and 1 in 4 died from heart disease, and so on. So why do you care? Again, you want to see if there is an epidemic going on in any from any of the diseases and so on. You also want to look at things like this: how many people are using the ER, because you need to know how many ERs you need, right? You want to be able to accommodate the demand. So if anybody who wants to set up a ER, right, they would want to know if there is a demand. Otherwise, why make one? And so on. So the number of births, everybody understand that's important, and everything else there. So health data is important to see. It's not just for knowing things, it's also knowing things and then what you need to do. And these are also used by businesses, so hospitals and all those businesses, so they would care about all these numbers as well, because they need to prepare according to the need or the demand of the economy, right? So Bureau of Labor Statistics, everybody knows that, we constantly look at the unemployment rate, right? If the unemployment rate is high, that's bad. If it is low, that's good, right? Import-export prices, right? So that's basically whatever you're importing and exporting, the prices of those needs to be kept track of, right? Who would care about those? All sorts of businesses who do trading overseas, right? They would care a whole lot about all this. So basically, most businesses are getting these numbers for free, right? They don't even have to do anything, right? Your company doesn't have to have a statistics department to do all this. There is an agency who is doing that for you, okay? So these are facilitating not just the government, they are facilitating all the private sector as well. So Bureau of Transportation Statistics, they look at airfares. So airfares went up by 4.7%, right? If you ask the Delta or some other airline CEO, at some point they said when the oil price went up to $4, they said, well, oil price is up. We have to take the prices up. And then when the oil prices go down, they say, well, you know what? We have to save up some money. We cannot still go down, and so on and so forth, So, but anyway, the airfares go up by 4.7%, and that's something that you want to keep track of. One thing for sure, though, is that I guess nowadays most companies are thinking about what's the biggest amount they can take out of your pocket. But they don't want to, at the same time, they don't want to take it so high that people are unable to buy tickets, right? So they know exactly how much exactly how much you'll be willing to pay. Highest amount that you'll be willing to pay. Volume of goods moving through our nation's ports, commuting times to work, again, commuting times, did they do it constantly because do you need to extend your highways? Do you need to make it better? Things like that. And I don't know if you guys use 75 for a long time now. 75 they have been doing work. Whenever I go, if I don't see anybody working there, I feel, a little bit angry that why aren't people working? But it's been there for a long time. These things do take a long time, I guess. Is that the last one? Probably it's the last one. Okay, so that gives you some ideas about some of the agencies in the government who do statistics for us. So you can go to their website in future ever if you need some sort of statistics like this. You can go to their website and then just get it for free. And nowadays there are also some, I guess, private companies who would provide you with data. So you pay them to collect data for you, and sometimes they already have data, so you can just go ahead and buy them. Okay. So there are some people who just do that, collect data and sell them. Okay. All right, so any questions, anybody? All right, so I just want to give you an example, and in this example I want to show you how when you collect the data, how it may look like, and then you do some calculations based on your sample, and you want to say something about, you want to make some inferences based on your sample and so on. So I'm going to use this 1936 presidential election. And it was between Alf Landon and Franklin Roosevelt. That's the only fact that I'm presenting you. Everything else, all the numbers that you're going to see are cooked up by myself, so they are not real numbers. Okay, the only thing that's real here is that election did happen in 1936, but all the other things are made up. Okay, so I was just lazy to look up the numbers, to be honest. So suppose that you are interested in looking at the voter preference in that 1936 election, and basically what you want to know is that whether voters prefer Landon or Roosevelt. Okay. So in order to study that, you're going to start by gathering data, right? So you're oops. Okay, so let's say you're going to gather data, and hopefully you're going to gather data in an unbiased way. Otherwise, you're going to get wrong numbers. So you select, let's say, 20,000 voters, and you ask them to fill out surveys. Actually, 20,000 is a very big, too high of a number. Usually, in most polls, probably no more than 3,000 or 5,000, I think. Okay. So most of the time, it's probably 1,500, 2,000, or 2,500. But usually, so I just picked a big number. So units. So in this study, right? What are the units? What are the units? Well, the units are the voters, right? The units are the voters. We are trying to say something about the voters, right? Not all people. Not, we're not going to include children in this study, right? So just the voters. And so the units are the individuals or the objects of interest, and in this case, that's the voters. Okay, what's the variable that we are interested in? So basically, what characteristics of these units are we trying to understand? So the variable that you're trying to study here is, well, we can just call it voter preference, right? Voter preference. Okay, and a measurement is a value of the variable for one individual. Okay, a measurement is a value of the variable for one individual. So what are the possible values of our variable? Once again, L, R, or none, right? Okay. So there are three possible values of the variable preference, and they are L, R, and none. So by not having the third option in reality, right, it's basically saying that, well, you better pick one of us, right? So, oops. Okay, so those are the options, and then the population is what? The population would be the collection of measurements for all voters, right? Remember, this is the statistical population, not the population of units. So the population is the collection of all measurements for all the voters in this case, right? So imagine that for all, you asked all the voters what their preference is and collected that. That's the population. So, but that's too expensive to do, right? So because of that, you just pick a small sample. So like I said, we are picking a sample. Again, sample here is just a collection of measurements for selected voters. And you have to infer something about the entire population from the sample. That's the goal. And we pick 20,000, right? We pick 20,000 voters in the sample. The question is now, how do you organize the data? In order to organize the data in this case, we will divide the data into three categories, right? L, R, and none, and tally the frequency of each category. Okay? So basically, we make what we call a frequency distribution table, and what that is the following. So it's a table where I'm going to have the category name, the frequency of each category, and the third column is the relative frequency, and I'm going to explain what that is. That's basically the percent frequency. Is everybody okay so far? So what I'm saying is that you follow some sort of process to collect the data, the preferences of 20,000 people, right? And you then organize the data in a table like this. And so you have the category name and the frequency of, so basically what we are saying here is that among the 20,000 voters that we picked in the sample, 8,000 of them said they preferred Landon, 9,000 of them said they preferred Roosevelt, and 3,000 of them said they preferred none, right? Now, what's the relative frequency? Well, what's the total frequency? The total frequency should be the same as the total number of measurements in my sample, right? Sample size, right? And so what's the relative frequency or the percent frequency? Well, that's just you divide the count of each category by the total count, right? So what you get is that the relative frequency for London is 40%, the relative frequency of Roosevelt is 45%, and the relative frequency of none is 15%. So that should add up to 100%. Is everybody okay with that? Any questions so far? Let me know once you're done copying this table. Okay, so from your sample, this is what you have learned, right? From the sample, you have learned that 45% of the sampled voters prefer Roosevelt, 40% of the sampled voters prefer Lyndon. And once you have this table, you can also represent this table by using a graph, and it's called a bar graph or a bar chart. So a graphical representation of this data would be the following. So what I did here is that along the y-axis we have the relative frequency. So what I did is that for each actually I didn't put the third category here, but you could also put the third category. So basically for each category you draw a rectangle, and the height of each rectangle is the same as the relative frequency of the corresponding category, and they all have the same widths, only the heights are different. Is that making sense? So for you pick rectangles of the same width for each category. You draw a rectangle with height equal to the count or the frequency or the relative frequency of that category. So here I took the relative frequency. So for Roosevelt, remember that the relative frequency was 45%, right? And for Lyndon it was I think 40%. Is everybody okay? Any questions on that? Okay. In the remember in Moodle I have this TI-84 instructions. So one of them is how to make bar charts there. You can also pretty easily use Excel and things like that. Excel is a little bit nicer than, of course, your calculator. And then from this, so you can present this bar graph to just a general audience, and they will right away know who's being preferred more, right? At least in the sampled voters. Now based on your sample calculations, right? You want to be able to project or predict something, and obviously no one's going to predict at this point that Lyndon is going to win, but we'll predict that the Roosevelt is going to win. However, if somebody just tells you that, should you really believe that? Maybe if I take another sample of 20,000 voters, the information will be drastically different, right? So how come I can even project that R is going to win? Especially when it's just 45 versus 40%, right? If it was like 90% versus 40%, maybe, right? So what you have to do is then, how confident can you be about your projection? So let's say that you can say that 95% of the samples of the same size, 20,000, will produce the same proportion up to an error of 1.2%. You are understanding that statement? if you can say that 95%, so think about all the voters, and there are all possible samples of size 20,000, right? There are many possible samples of size 20,000, right? For example, if you are the voters here in the class, there are many samples of size 5 that I can pick from this sample, from this class, right? Is that making sense? So look at all the possible samples of size 20,000. And what we are saying here is that 95% of the samples will produce proportions, the same proportions, 45, 40%, up to an error of 1.2%. So plus or minus 1.2%. So if you think about it, that means most of the samples will tell you, 95% of the samples will tell you who's winning. Roosevelt, right? Because that error is small enough that there is still a gap between the two, right? If that error is 6%, if this error is 6%, then no one should listen to you, right? But if it is only 1.2%, then we are saying 95%, from 95% of the samples, you'll see that Roosevelt is winning. Okay, so that gives you a confidence that to say that Roosevelt is going to win. Right? Of course, it's 95%, not 100%. Right? Is that okay? So when you read those polls, you have to also look at the error. Okay. So sometimes there might be a gap of 2% between the two candidates, but then the error is 3% or 2%, and then it's that poll is of no use. Or I shouldn't say no use, but it probably simply means that it's just too close to call at that point. Okay.